Welcome everybody. Welcome to this lecture, and I'd like to welcome you on behalf of the faculty. I'm the Deputy Dean, Andrew Hudson. The Faculty of Architecture, Building and Planning is physically hosting this talk by Professor Mark Stevenson today, Understanding the Complex City Decisions for Healthy Future Cities. Now, Mark is an interesting academic. We are hosting him within our faculty, being a Professor of Urban Transport and Public Health, but he's an epidemiologist, which he'll touch on, I think, in the course of his lecture, which looks at this combination of the urban environment and health, and how you can, what one might mean to the other. And it comes from a number of different directions and incorporates within his collaboration of the research a number of different disciplines. His appointment to the University of Melbourne is across a number of schools, to the Melbourne Schools of Design, within which we find ourselves, Engineering and Population and Global Health. He's a National Health and Medical Research Council Research Fellow, an Honorary Professor in the Peking University of Health Science Centre, and an Advisor for Injury to the Director General of the World Health Organization. Professor Stevenson has worked on numerous national and international projects and has directly influenced transport policy and worked with both federal and state governments in Australia and internationally. He's led many research groups and is internationally recognised in the field of transport, safety and public health. Professor Stevenson is currently Director of the Transport, Health and Urban Design Hub, which is the acronym turns into THUD, which we quite like, because we hope it has impact. This comprises a cross-disciplinary research team which explores the effects of urban form and transportation and the influence on health and residents in cities. The research hubs, of which THUD is one, in the Faculty of Architecture, Building and Planning, is part of a program that was established to enable the collaboration of teams within the faculty and outside to engage with major research themes. THUD is an interdisciplinary hub and is an exemplar of how such collaboration can tackle large-scale urban issues. In this case, the whole is greater than the various parts. So I'd like to welcome Professor Stevenson to commence his lecture, and if you can join me in welcoming him to the podium.
Thanks. Okay, I assume I'm wired. Is that right? Great. Look, thanks very much, Andrew, and it is a privilege to be here tonight. And it's probably nice for me to, I think, to start thanking you. At 6:30 on an evening, it's rather cool out there, and the numbers turning up is fantastic, so thanks for the support. What I'm going to present is probably quite different to what typically an epidemiologist would present, which is, for those of you who aren't familiar with that discipline, it is the study of the distribution and determinants of diseases in populations. And I'm going to sort of allude to that a little bit tonight, but I'm going to talk much more so about our cities and particularly where we need to go in terms of 21st century cities. And this is the outline. And I am certainly no historian, but I felt it was probably a good start tonight to look at the historical context of our cities from the 17th century forward, and then move over a few hundred years. And no historian would probably do that, but I'm going to just jump from the 17th, 18th century through the 21st century and talk big data. And that won't be new to anyone here, I'm sure. And then move through to understanding the complexities of our 21st century cities and how do we begin to unravel some of that complexity. And I'm going to just give some illustrations of that in relation to some work that we've been doing, looking at land use, particularly land use, transport, and the health of various citizens in a number of cities around the world. And then conclude with a sort of a grand piece that we're aiming to pursue over the next sort of 5 to 7 years. And I'm going to just talk about that in terms of, it's a piece referring to informed public policy that really will, I believe, unravel that complexity and begin to give us some very good evidence to inform public policy, particularly around decision making for infrastructure and 21st century cities. So this is the journey, and it was fascinating just even thinking about this. Some of the slides that I'm going to use in this first historical piece are slides that I used when I was teaching medical students about 20 years ago, and in fact have come straight back into this piece because they sit nicely when you try to begin to understand the spatial distribution of diseases in our cities back in the 1800s and the 1700s. So the health of city residents and city design, a historical context. So the health of cities is linked to the complex interaction of exposures, the environment, and the residents of those people in the city. And that, in essence, I sometimes feel that I am an imposter here as an epidemiologist amongst, particularly in the School of Design, amongst planners and architects and construction management. But when you see that and that statement, it really highlights the sort of work that an epidemiologist does. We look at the interactions between exposures in our cities, the environment that we live in, and the people. And it's an important element of our city that we need to explore. And importantly, it was explored. As early as 1662, John Grant here highlighted in this Bills of Mortality, a city, as it becomes more populous, doth not for that very cause become more unhealthful. It's probably the only piece of medieval English I could understand, but nonetheless, what it highlighted is back then, in the 1600s, they were highlighting the challenges of health in our cities. And those challenges back then were very obvious challenges. They were the waste, there was the putrid smells, there were the rodents, there was a massive overcrowding, the poor quality of housing, if any. And that's what was being captured. And what the scientists of the day, and what's sort of outlined in some of those bills of mortality, are some of the theories that were hypothesised as early as the 16, 17, and then into the 1800s. And that well-known theory was the miasma theory. And that really basically highlighted that the putrid smells were transmitted and the diseases were transmitted in the air. And that's what the miasma theory was. And so basically what it was highlighting to city planners, to city governance at the time, was that our cities needed to be changed. They needed to be planned and designed to grapple with this challenge, this theory that was causing the burden of disease that was rampant throughout the cities in London and the big metropolitan areas throughout Europe. And interestingly, Melbourne was also very much the same. This piece that was written by Ingalls here just recently, looking at the historical elements of Melbourne, the health and planning policies in the 1800s in Melbourne also reflected the challenges of the time in terms of the miasma theory, and it influenced some of the designs in Melbourne itself. Now, Melbourne was growing exponentially in the 1850s as a consequence of the gold rush, but you can see from this picture here the very wide streets. They were encouraged not only so that the horse and cart could turn, but also because of this pervasive miasma theory that was prevailing across all cities in Europe and now in the New World. And that was pointing to the need for clean air to pass through these canyons in the cities and dispel the infectious diseases. And the infectious diseases of the time were certainly cholera and bubonic plague. And interestingly, both of them are bacterial diseases. One is through contaminated water, cholera, and the other is through fleas and being bitten by rodents. And so you can see even from this that Melbourne was planned on the basis of some of the health policies of the day. Now, I'm being really naive here because certainly it's not the case, not entirely, and I'll come back to that later in this session. Interestingly, though, Melbourne was not alone, and the very famous cities such as Paris, for example, also went through this transformation, this incredible transformation. And in fact, what we see here with Paris was that when Louis Napoleon Bonaparte came back from exile from London in 1848, he came back to a Paris that was putrid. It was dark, dank, it was disease-ridden, it had no sewerage systems that were being developed in London, and as a consequence, he transformed the place. And in fact, just thinking about this, and I really quite like the jargon that's used in the School of Design and in the building environment, in the built environment and the professions there, but this term placemaking, I often think really probably got its roots from Bonaparte here, because he really, truly, he demolished most of Paris and in 17 years rebuilt it with massive avenues, partly, of course, to deal with the miasma theory, but also to deal with the infrastructure that was needed for a rapidly growing city. And it's incredible to think that in 17 years, they demolished 12,000 houses from 1848 onwards, demolished 12,000 properties, they built parks, they established gas lights, they created, the reason why it's now called the City of Lights is because of that, and they created an amazing sewerage system. And it transformed Paris. In part, the impetus for that was the health of its citizens. So it makes a lot of sense to think about health as an outcome in our cities and how it might drive the urban form and other systems and how particularly they interact. Continuing with that historical theme then, what I'm looking at here is that slide that I used in my lectures to medical students, which was really the evolution of the field of epidemiology, which was in around the 1850s. And this is what dispelled the miasma theory back in 1850, 1860s. A chap called John Snow, who studied the deaths around various wells in two areas in London, Suffolk and Vauxhall areas. And it really was the beginning of, for many of you who may be from the geography area, the beginning of GIS. He presented the data spatially and illustrated clusters around water wells. And those water wells that were upstream in terms of the Thames had much fewer deaths than those who were downstream around contaminated water. And so for the first time, John Snow was able to say, actually, the way this is, where our water wells are and where people are getting their water in the city is actually influencing the spread of this disease, this dreaded disease that was rife throughout the large cities. Now, at that time, we still didn't know what was causing cholera other than where the source was. And so they simply took the well handle off and straight away, basically, the rate of deaths declined. I wish epidemiologic research was as simple as that. But at the time, it was obviously incredibly challenging as well, and it dispelled the myths around the miasma theory. But importantly, evidence is not sufficient. And as we see in 21st century cities, evidence is not sufficient to get the change that's required. And in fact, it took many, many years, probably about 20 or 30 years, until Louis Pasteur identified the germ theory, that we started to see a change in the medical fraternity and the miasma theory no longer espoused as a cause of disease transmission. And at that time, we probably started to see a change in the design of our cities as well. They weren't as influenced by the health outcomes of its population, but a whole array of other outcomes. And just to conclude that section then, the health of city residents is influenced by the urban form. And right back from the 1600s, we can see that. And actually, there's some unique parallels as well. The parallels in terms of 18th century city governance and how they managed city spaces to control infectious diseases to really what we're seeing now in the 21st century in terms of our city governance and managing city spaces in relation to health outcomes. I'm not calling it disease outcomes. In fact, what we're doing now in the 21st century is not so much focusing around our infectious diseases, because the way our cities are now designed is we're actually seeing considerable burden associated with non-communicable diseases and our chronic diseases as a sign of and as a symptom of the way our cities have been or have evolved. Maybe not so much designed, but have evolved. So going from that 18th century right through to the 21st century, like that, we're now on to big data. And you probably didn't come tonight thinking I was going to talk about big data, or maybe the inverse of that, you probably did think, you come to a university, we are going to talk about big data because everyone's talking about big data. I mean, maybe for the first up, let me define big data. Big data is significantly large data sets which allow us that allow anyone to analyse them computationally, and allows us to look at trends and patterns in that data. And this really is, we sort of throw big data around and we talk about the 21st century city, and we talk about the uniqueness and the application of these tools to understanding our cities. But I just want to regress a little bit and just say that in fact science and cities is not a new concept. In fact, Professor Mike Batty, who's sort of a luminary in urban planning, basically stated in his text, his book on the new science of cities, that the science of cities it's not new. It's been around a long time. But what we're trying to do now, and what we need to be doing, is integrating the science so that we begin to see how the science plays out across the varying urban systems. So big data is valuable in that regard. It allows us to look at data in a novel way and to address and begin to address the complexity of science. Complexity is a challenging area, but it's also at the same time an exciting area, and it allows us to think about, typically, let me just think about in terms of my discipline, we would typically look at key risk factors that might contribute to cardiovascular disease. We might measure those risk factors and then determine whether they are increasing the incidence of cardiovascular disease. And when you think about those sort of relationships, they're quite linear. This risk factor contributes to this outcome. And what we're very much focused on around the complexity of science is understanding how various inputs may affect multiple outputs, and vice versa, how many outputs might affect multiple inputs, and how do they interact with each other. So big data has the potential to give us quite considerable new insights in our 21st century cities, and particularly new insights that give us a focus around the health of our cities and the sustainability of our cities. And this is some of the exciting work that we're starting to begin to look at in THUD, in our Transport, Health and Urban Design group. So the aim of our THUD is to explore the effects of urban form and transport on the health of city residents. Now, as I've already highlighted, complexity is and can be multiple things, and it can be multiple urban systems. But what we're attempting to do in this grouping is look at the relationship between our urban form, transport, and health outcomes. So I thought tonight, okay, what pieces of work? I've got some amazing scientists in this group who come from varying disciplines. Some are climate scientists, others are mathematicians, some are engineers, and there's an array of work that we're looking at. And I thought this one might be just useful to just to capture some of the imagination of the potential for using big data to look at the health implications of our cities. And this is led by one of our Dutch researcher here, Dr. Vineyards. And he's looking at this new technique for healthy future urban design based on big data and artificial intelligence. Now, many of you probably watch Four Corners. You'll know probably what artificial intelligence is all about. It's taking over basically everything. The perception is it is. There's a whole bunch of limitations with it. But on the flip side of that, it's quite exciting in terms of using it to look at new applications. And in this instance, what we've done is say, okay, we're using this technique called generative, generative adaptive networks, I think it is, something like that, where we're taking big data, and in this instance we're using Google Maps, and we're also taking health data from the health department, a general health survey, and we're beginning to use this machine learning approach to explore urban design. So in this instance, we took the Victorian Health Survey. There were 34,000 randomly selected respondents in that survey across Victoria, and they completed a survey that sought to identify whether they perceived they were in good health or poor health. It had measures of things like social capital, the connectedness in your community, those sorts of concepts. We then also accessed the Google Street View images for Victoria, and we sampled these, and it says here we selected about 160,000 images. Now the nice thing about using this Google Street View images is that you can download, you can randomly select a whole array of images and assess how they fall out in relation to whether the people who had good health resided in certain areas and whether people with bad health resided in different areas, and what are the images of those good areas and what are the images of the bad area. Now, what this application did, now this is meant to be a bit blurry, so it's not just a bad photograph. On the left here is what we see in a randomly selected image that identifies a location in which residents were of good health. And then what it does is it encodes the data and then it decodes it again, and it generates what that image would look like if the residents were of poor or poorer health. And it's very distorted because it's a regenerated image. And this third image here is something we've just created ourselves to try and make it a little bit clearer about what we're trying to do here, and it may not make it clearer, but what it's shown here is that there are differences in the pixel colours between the two images. On the left, you can see it's quite green. On the right, the bad image, there's fewer green areas. The big difference too is up here, which is showing that the height of the trees is also very different. Now, what this is saying is this is not something we have done. It's done this multiple times and takes a long time to generate these. But what it starts highlighting is that areas of good health also reflect areas where there's green space. And there's a lot of discussion around the role of green space in terms of our health. What this is giving us is a computational outcome, not influenced by us, that's showing that these areas where the Victorian Health Survey says there are healthy people, they tend to be greener, they have larger foliage, and so on. Now, there's a whole bunch of other elements that we need to explain and would need to explain to draw any causal relationships between this, and we're not doing that. But what we're trying to highlight here is that using these new techniques, you can start generating areas that reflect good health and areas that reflect poorer health. This is another one, which is another image of, on the left-hand side there, is an image of good health. This is the regenerated area if it was to become poor health. And this one doesn't really reflect the big differences in the pixel colours a great deal. But what it's showing is that the areas of good health are much more compact. They're closer to the road network. They are often maybe mixed use. And what we're seeing is if it was a poorer area, they're further away from the road. There's greater space. And so it's highlighting potentially maybe what's discussed in the literature a lot around the health gains of compact cities versus other types of cities. So these are very early illustrations of the sort of work that big data using different computational methods and freely available data can begin to unravel in relation to understanding our cities and how better to maybe design them in terms of its built form. So moving from big data then to thick data. Now, that seems crazy, but thick data has been around since 1973. And what we mean by thick data is that applying almost a sociological perspective to big data. What it's saying is that there is an amazing array of technology out there now. There are sensors in our networks that give us a huge array of information, whether it's about noise levels, whether it's about air pollution or emissions from our transport system. And what thick data says is, it says, let's begin to enable the citizens to come together and access that big data so that it can be used in a positive way to influence our environment and influence our city design. And this is just one example of, this is Plaça de Sol in Barcelona, and basically what the citizens in that area did was mount noise sensors throughout the square. And they came together and they actively pursued the city governance, the city council, to make radical changes around noise in that area. They had spent years dealing with the challenges of the parties and the noise in that area, and they were able to become activists through using big data as such, and have a value and have a discussion with their city governance or with their city hall to work through strategies to minimise that noise. And we know that noise has significant implications now in relation to our health outcomes, and particularly depression. So there are a whole array of interesting ways now of using big data for citizens to be advocates for change in relation to urban form as well. So that leads us then on to the complexity of our cities. And this is a fascinating area because there's generally a perception that if you have good transport, you'll have good housing. Good transport might support good housing. Good housing will support good health, and ultimately, a strong economy. But the inverse of that is that, in fact, the interactions between those various urban systems could become highly vulnerable and are highly vulnerable. And it's not a given that you provide good transport system, you'll end up with good housing, and that will support the good health system, and that will support a strong, growing economy. And what we need to understand is that there is an interaction of all of those urban systems, and how it might play out is key to understanding our urban form and how it plays out in a 21st century city. So we, at this stage, have a limited understanding of the interactions between the numerous urban systems that make up our city. And we need to begin to understand the complexity of those urban systems. So what I'm just going to talk about now is I think, a very crude way of beginning to explore that. It's something we worked on for a number of years, but having said that, it is still very limited in its application. But nonetheless, even though it has limitations, it actually provides an enormous insight to how various urban systems interact and have an influence on the health of our citizens. This work we undertook in 2016 here at the university, and it was published in a series in the medical journal The Lancet, and it was a series called Urban Design, Transport and Health. There were 3 papers in that series, one led by Professor Billy Giles Corto from RMIT University, and the other was where is his name here? He's not on here. James, I'm trying to think who it was. He's not here. Sorry. Let me skip. It was Professor Jim Salas, who was from the University of California, San Diego, but he's not listed on there, sorry. So what we wanted to look at in this paper, and this is the one I led, was we wanted to look at the relationship between land use, transport and health. Up until now, there'd been a lot of discussion around the influence of land use on transport choice, but they hadn't linked it then to health. And so what we did in this paper was do exactly that. So we know that we live in a rapidly urbanizing world. We know that by 2050, that 70% of the world's population will reside in a city, and with that comes substantial challenge. Importantly, and this is what I was particularly interested in, was the land use choices that we have in our city influences the transport that's delivered in that city, and that influences the health of its residents. And I wanted to quantify that relationship, and it's beginning to break down that challenge around complexity that I have been talking about. And in this instance, I'm just going to give you two illustrations of what effects land use, transport and health have. Our transport system has significant effects in relation to air pollution, particularly in cities like Melbourne, which are car-dependent cities. And I've listed here just the areas that have major effect. So air pollution, and what we're talking about with air pollution is a thing called particulate matter, 2.5 and 1, or 2.5 and 10, I should say. And it's the very fine particulate matter that affects your lung. So we can clearly see that we get a whole array of respiratory tract conditions associated with that sort of level of air pollution. But it also affects our heart, our reproductive system, arteries, and it also affects some of the areas in the brain as well. And the other is the lack of physical activity. So a very car-dependent city means that you have reduced levels of physical activity, and that in itself has substantial implications in terms of our heart, in terms of heart disease, respiratory tract as well, and particularly areas like diabetes and obesity. So we wanted to look at the relationship, as I've said, and we wanted to look at it in relation to transport mode choice for people in various cities around the world. So we looked at this, health gains from creating a compact city that adopts low motorised mobility. So what we were interested here is that for a number of you, you may be very familiar with the United Nations Sustainable Development Goals. They were announced, I think, in 2015, I think, when the Millennium Development Goals ceased. And they are, whereas there's about 196 countries have agreed to 17 goals that are development-related goals. And two of those goals are related to sustainable cities and to good health and well-being. And so what we saw this piece of work doing was giving cities and giving governments an opportunity to look at how they might begin to address and make a response to those sustainable development goals, which can be perceived as quite lofty. So what we said here is let's just look at what health gains might occur if we created more compact cities. A compact city is a city of short distances, so shorter distances between your house and your public transport, shorter distances between schooling, educational facilities, and the like. We created this model. We use what we call a health impact assessment framework. It's predominantly used often in environmental impact type work, but it's used extensively also in health policy as a mechanism. We looked at land use, and land use can be broken into a whole array of dimensions. We just looked at a number of the dimensions. We looked at distance, density, the density of properties, distance between house and or place of work and public transport, and we also looked at the diversity of property. So looking at multi-dwellings, whether there were amenities close to your place of residence and the like. We then looked at the transport modes. We looked at walking, public transport, motor vehicle use and cycling. And we looked at a number of risk exposures associated with those transport modes, car crash, emissions, air pollution and obesity. and we created this health and wellbeing indice. When I say we created it, it was just a standard indice that's used by the World Health Organization. It's a concept called a disability adjusted life year. It's a very powerful metric in that it takes account of the premature years of life lost as a consequence of that disease, and life lived with a disability as a consequence of that disease as well. We then looked at an array of cities, and we chose these cities in order to give us some contrast between cities that are highly motorised, like Melbourne, high income, like Melbourne, cities like London, which are mixed use, but high income, and Boston, which is also highly motorised and mixed use, highly motorised and high income. Then we looked at Delhi, which was a middle-income country, a lower middle-income city, but rapidly motorising. We looked at Sao Paulo, which was a middle-income, higher middle-income city, and also rapidly motorising. And then we looked at Copenhagen, which is sort of renowned worldwide for a very multimodal transport system, again, high income. And interestingly, the data from each of those cities, we looked at their travel survey data, and it highlights exactly what I've just said. That you can see in Melbourne, we're a highly private motor vehicle oriented city, as is Boston. London, variations on that. Delhi, really mixed mode. And you can see here Copenhagen, is certainly a real mix of public transport, private motor vehicle use, and cycling. So what we wanted to do is say, okay, well, what if we were to change that city, each of those cities, in a way to make it a little bit more compact? So what if we said we modelled a compact city scenario, which is 30% increase in land use density, reduced distance to public transport by 30%, increased diversity of land use by 30%, and a transport policy that supports a 10% modal shift from private motor vehicle VKTs, vehicle kilometres travelled, to cycling and walking. So what we're saying here is a 30% change would mean that I think on the whole, it was something like a trip from a house to public transport might be 2.3 kilometres on average. It reduced it down to like 1.8 kilometres on average, something like that. I can't remember exactly the numbers on that. But the transport policy getting a 10% modal shift was actually really conservative, because 14% in Melbourne, 14% of all car trips are under 5 kilometres in distance. So in fact, it's quite feasible to be able to try and move those vehicle kilometres travelled into an active form, like walking to public transport or cycling, for example. So really what we were doing is trying to move, we're increasing the density of our land use and the diversity, and the density, distance and diversity, and we were moving some of the transport modes out of private motor vehicle use and into public transport, buses, trains, and walking and cycling. We looked at the risk exposures as a consequence of those changes, and we estimated the health and well-being in each of those cities as a consequence of those sort of changes. So what I'm highlighting here is we're beginning to try and bring an array of urban systems together. Our urban form, our transport system, and in this instance, looking at our health system. Now, ignore these numbers other than at the bottom here. Really what we're seeing here is that this is population health outcomes, and unless you sort of have worked in public health or in the medical area, you're probably not familiar with this term that I just highlighted, but basically what it's saying is these are very positive health gains that occur as a consequence of those changes that we just talked about. Those land use changes, those transport modal shift change, that transport policy, a sustainable transport policy, you get health outcomes, positive health outcomes from them. But actually what you do see is, you get variation in each city. So it's not something you say, well, you do this here in Melbourne, it's going to happen in Delhi. It doesn't. It's not exactly the same. And interestingly, you actually see this negative number here means that policy change that we just advocated for in Melbourne will increase trauma. So it'll increase, this instance here, any negative number means it's going to increase the problem. So road trauma is going to increase, actually. So it's not all positive, and this is what we mean, what I meant at the beginning when I talked about complexity. And complexity means the outputs are some instances positive, some instances negative. But you need to begin to understand the implications of those. And that's what this is beginning to do. Yes, there's positive elements in that, in understanding that land use, transport and health outcome in relation to a number of health outcomes. Particularly though, they're particularly chronic health outcomes. They're ones that aren't acute. They take a period of time to occur, many instances, many, many years. The challenge though is road trauma is acute. It happens here and now. So that change that we're just advocating, a compact city and a move to more active transport out of private motor vehicle use, does actually say you're going to increase the level of road trauma in your city. Although, actually, when you look at Copenhagen and Delhi, you actually see almost very, very little change. And there's a whole array of reasons for that. I'm not going to go into the details of Delhi, but Copenhagen, why you don't see much change here is Copenhagen's already designed its city for that type of transport mode choice. It has amazing infrastructure for walking and cycling and better public transport. So I couldn't leave the paper then just saying, well, if we moved into this more sustainable transport policy in Melbourne, we're going to have more road trauma. So what we wanted to look at is, well, what sort of changes would we need to do in Melbourne in order to mitigate that road trauma? And what that showed here is that the percentage of separation of active transport vehicle kilometres travelled from motorised traffic, it would need to be, where's the positive numbers here? We'd need to start changing that VKT by about 55%. So what it's really saying in Melbourne, we'd need to have a significant change in infrastructure to mitigate the road trauma if we started moving people into cycling more. And I think that's an important message for our city governance as well, that this is an important sustainable measure. There are a whole array of health gains as a consequence of this. We need to look at the infrastructure to deliver it though. So just to finish this complexity in our cities question, there is a complex relationship between land use, transport and our health, and I've just illustrated that. But what is important is we need public policies that need to target the health of growing populations. We need to ensure that we put a health lens over what we're proposing in terms of our urban design for our cities. As we probably do if I was an economist, we'd need to think about the economics of it as well. As if I was a planner, I'd need to think about the land use elements and what policies are important and sustainable in that regard. We need to consider all of those elements together. And I've highlighted here, in that scenario we gave that I just discussed, clearly there was a need for infrastructure investment that supported that. So that leads me then to the final point tonight, and I'm taking a bit of time, which is inform public policy to contribute to the delivery of healthy and sustainable future cities. So bringing all of this together, what we're wanting to look at over the next 5-10 years is to bring all of those disciplines that have such a significant role in how our cities play out together to understand the implications of how the city can be built to ensure that it is healthy and sustainable for future generations. This is some of the work that we're proposing at the moment. So we're proposing to bring a number of leading scientists from around Australia to look at these questions. And what we want to focus on is expanding city observations. Now, you would expect to see that as in an academic institution, that we obviously need to collect more data. But what I would like you to take from this presentation is that it's not just getting new data, it's taking existing data and it's providing it from the bottom up to the citizens so that they are very aware of what is happening in their environment and so that they can drive the needed change that is for sustainability and healthy in our future cities. So what we want to focus on in this piece of research that we're talking about over the next sort of 7 years is that we want to take we want to expand the city observations, and we want to look at it in terms of thick data as well as the big data, so that it can be influential in the decision making. We need to enhance the science, and we need to understand the complexity of urban systems. And this is a new field. There are a whole array of new techniques evolving in this area, and we want to embrace those, and we actually want to lead those new areas of complex science. And we're looking particularly at colleagues in the mathematics and statistical areas, in the computer science area, and also in the social science area. And along the way, we want to ensure that what comes out of these relationships is input straight away into the community in these living labs. So we can actually look at, well, how does that play out in real time? And there's a whole array of new techniques that we can use real time to explore that, which is phenomenal. Now, along the way, we've got this thing called an adaptive learning hub and a public policy decision platform. All of this research needs to feed into these two key elements. A public policy decision platform, it's a digital platform that we want to be able to feed the science into to enable government, industry to be able to look at the complexity of what we're talking about and run simulations and begin to understand what the implications might be of various infrastructure investments, for example. Or it may even be various sustainable transport policies, whatever it may be. We need to begin to understand it in this way that allows us to run scenarios, run simulations with the best data we can get hands on and the best science around it. But importantly, we also want to look at, well, what's happening here and now as well. And now the digital disruption has major influences on how our cities are playing out. And it's important for us to begin to understand that as well. So we want to integrate that into all of what we're looking at here for our future city. And finally, to deliver what we're talking about and what I've just highlighted, it requires an enormous amount of leadership, and it needs potentially maybe even governance change. And what we need to look at is, how do we support the transformation of cities in relation to its governance? I think that's incredibly important. If you think about our cities, they're built on a system that, a governance system that evolved in the 18th century, and we're operating in a 21st century. We need to understand what implications does that have. How do we change that if we need to change it in order to deliver, profitable, safe, equitable cities in the 21st century. And I'll leave it at that. Thank you.
Thank you very much, Mark. Don't go too far
Okay.
away. Thank you, everyone, for listening and being in attendance to what was a very interesting and very, in many ways, provocative conversation about how we understand our cities and the complexity of those cities. And in some ways, it's heartening to know that the research that's undertaken by Mark and his team is actually looking at complexity and trying to embrace the complexities, rather than having fear of them, rather than trying to simplify things, get the sort of an easy solution out of it all. And I think that that degree of understanding of complexity and how it works with the relationships of our cities, in some ways might be the equivalent of taking the handle off the wellhead. And hopefully that might be the case.
That's a good analogy.
So anyway, just join me again in thanking Mark for his